This paper was presented at the JCT Traffic Signal Symposium 2025. Video coverage of this paper is provided by Highways News and sponsored by Mobius Networks, AGD, Smart Micro UK, TRL Software, Traffic Group Signals, AD Electronics, and Four-Way Consulting.
So what I want to talk about is the IOT, and this is to do with a scheme. So that's what it's about. And then I do next to her. Clicker. Here we go. 30 years in technology and I can't work a laptop. So this was to just a short presentation, a little bit on a sensor that we have, which is new to our portfolio. That's just changed on me. Did that change there? No? Okay, good. So this is the idea of this sensor is to be, if you don't have infrastructure and you're looking for data collection, and you need something where you don't need any maintenance and it's long-lasting, cost-effective. So, bear with me. So the way the sensor works is basically core drilled, put into the ground, and you forget about it. So the data is sent once a day into the Sensebit's cloud, and you can actually, say, aggregate it with every detector that's kind of on the market. So there are the classes you can get from that from the sensor, and if I show you very quickly, the installation is pretty straightforward. You kind of core drill, minimal traffic management. We're also actually just talking to a couple of companies about actually putting an enclosure in there. So should you ever need to remove. So this all feeds into the Sensebit cloud, and as you can see, there's different technologies in there, and that allows you to take data from various sources, and we can produce reports. And I can show you on that on later on if you come and talk to me on the stand. So again, this is C&T Technology. We have a product range which includes AI video detection, wireless sensors, radar detections, radar traffic counters, speed signs, counters and classifiers, and data analytics. So that's kind of a bit of an overview of our portfolio. So I want to talk about Glasgow now and a specific case study. So this is to do with our radar detector, which is the TMB133. So traditionally, cities like Glasgow used induction loops, as we all know. But the weather and the roadworks in Glasgow was causing a lot of problems with loops and a lot of failures. So obviously when you've got scoot links down, you then got traffic management for you need repairs. And basically what happened was that Glasgow approached a few companies and they were looking at above ground detection solutions. And we were one of the companies they came to. So just to give you an idea of the population of Glasgow, it's say 1.8 million, a lot of traffic, and every time a loop was failing, they've got to do, like I say, digging up the road, which then causes more delays. So instead of solving congestion, sometimes it made it worse. So Glasgow City Council came to us and they asked about the ICOM's TMB134 radar. So basically this can be mounted on a primary pole. It can monitor more than a lane at once, so it can do actually up to 4 lanes. Obviously, with it being radar, works day and night, so you don't have any issues with lighting. And it also detects moving and stationary vehicles. Very good at bicycle detection. Has a range of 120 meters. But best of all, for me, is the installation takes a few hours, even quicker than that if you've got a good installer, not weeks. No TROs, no traffic management, no road space bookings. So, say you can mount it on an existing signal pole. So for the trial, we installed one at London Road and Clyde Gateway, which I'll show you a bit more about in a minute. And you can define up to, it says 3 zones on there, but we do have a 1, 3, 4 version where you can have 9 zones. And the vehicles say, you know, they're activated by bicycles and vehicles, not pedestrians. So this is an example of a scoot loop problem, let's say. So it's been patched through. You can see the duct in there is trashed. So they needed to find a solution to that because basically there was no ducting or infrastructure between the traffic light controller and the scoot loop, which is about 80 meters down the road. So you can see on this one here, basically we've kind of given a measurement. You can see I don't know if you see at the bottom there, that's where the scoot loop is. And that's where it's back to the stop line, which is about 82 meters. What we had to do though, because we got those trees in the line of sight, granted we did have to pull it towards the traffic signal controller a little bit nearer. So we lost that distance. However, it wasn't a particularly heavily trafficked link, so that wasn't really an issue. What it meant was when they did get it working, you weren't working on default timings for your scoot link. So hopefully this will work. Bear with me. Is that the right one? Okay, so this is a bit of a video. So what we have here, I've kind of tried to overlay. Can you see my mouse there? You can't. So I've overlaid the screenshot from the laptop at the bottom right-hand side of the screen, and obviously you can see the traffic in the background. So this is like free-flowing traffic example. Bear with me. So you can see the vehicles going along there. So what you've got there then is a loop that's roughly about 60 meters back from the stop line. Oops. So I'm going to show you an example of a busier site. So this is Mount Vernon Avenue, which is quite a busy intersection coming out of Glasgow. As you can see, it's quite a major road coming out from the city centre. That's a bit of an overview of it. So this site, they have installed a detector on each primary pole for the 4 directions. And you can see there as well that the lanes go from one, and you've got 2 lanes. On some of the approaches, you've got 2 lanes. So this is one particular approach that I've chose just to show you. So this is, obviously, you've got 2 lanes, you've got a straight on approach and a right turn lane. Now the phasing is actually, it's not split, they both run together in opposite directions. This is the installation itself. I personally wouldn't have used that bracket, but that's what they're using in Glasgow. There are some better alternatives around. You've probably seen them on a few of the stands around here. So, but it's kind of straightforward to install. You can put it on the bracket, you run your cable into your signal head and then into the pole cap. So this one has 3 internal relays, so you don't need to worry about any interface cards. So yeah, and again, you just pick up the 24 volts in the traffic signal pole if there's one there. If not, you just pick up a couple of spare cores. So just bear with me. So what you have here, you have the VA zone, which is a 40-meter zone, and in the distance you've got the scoot loop, which is showing at the top. So if I just pause that. So as the vehicles are moving away, you can see that the 40-meter zone, which is the VA zone, is activated as red. And what you'll see in a few seconds, you see where the bus is, the zone's just in front of that. So as that bus pulls away, you'll see the scoot loop go. So there's that bus just moving away. You can also see where the vehicles are tracking. So if you want to, Glasgow should have probably made that zone a little bit wider because you've got the second lane. Because that's traffic moving along, you can see the scoot loop operating and the VA zone operating. So again, we've got queuing traffic. You'll see as the traffic starts to move away, because that zone at the stop line is a moving zone only, but in the one in the background, again, you'll see the scoot loop changing state. So that's all done with one detector mounted on a primary pole, and that at the moment is about 60 meters back from the stop line. We've just brought out a new version of the firmware, which will get us to about 120 meters zone range. But to be honest, I think you'd be looking at about 80 meters. I think yesterday when I looked at the Topaz, they were talking about the different loops and the accuracy and what they're going to be aiming for. It's like I saw the figures and my eyes lit up, to be honest. It was really good to see. So they're not asking for 100%. I don't think you'll ever get 100% on a radar detector. So that's the couple of case studies. So Glasgow have, sorry, that's twice. So Glasgow saw the benefits. A lot of first-time saving, no need to dig up the roads, installation done and setup is done in a few hours. I can show you how the setup is done on the stand. Sustainability, so there's no waste from debris from the loops, less people stuck in traffic jams whilst the work's going on, and the flexibility, and that's a really important bit. If you need to move the zones because something's changed, you can just go on site and get an engineer to do it for you, or do it yourself. Just one point here, it's really good at picking up cyclists. So I was really lucky there. I got a picture of a cyclist sat at the stop line. I don't know if you can see what the little green LED's on, because it's got him picked up there. So the results were impressive. The radar worked 24 hours a day, all the weather conditions, and the council were satisfied with the performance, and so much so they probably bought somewhere in the region of about 100 units off me over the last 12 months. So, not me, off the company. So in summary, it's a cost-effective, sustainable, flexible solution for Glasgow. Less congestion because they're getting things fixed quicker, less maintenance, smoother traffic flows. And it highlights the potential for radar detection to become part of a smart city infrastructure. And the key takeaway is the above-ground radar technology does actually work. It's been proven in real-time city environment, and it's just not a replacement for loop. It's a step towards other things. There's an RS485 output on it, so you can get data from there. There's also, we've just added a count facility, so we can draw a count at the stop line, so you can actually get some traffic counts as well and a bit of classification. Sorry, excuse me. Nearly done. 2 secs. This is another radar detector I just want to tell you about.
Relay outputs.
This is really simple VA
One
detector.
activates when a vehicle moves within a 40-metre area
40-metre zone,
the traffic
and it has
pole.
a stop line zone.
The second relay activates when
Again,
a
this
vehicle
has
moves
proved to
or
be really
stops
successful
within an
in Glasgow
adjustable area
and
at the stop
Scotland
line,
as well,
either
surrounding
10
other
or
areas of
50
Edinburgh.
metres. These can be a normally open or a normally closed contact. The range can be easily adjusted according to the specific requirements of the junction.
So this can do up to 2 lanes. So again, if you're looking at VA detection, cheap a solution, especially if you've got loops that are down and need to be recut, you can put one of these up. Again, really good at picking up cyclists. So this junction here, is this coming up? Yeah. So this junction here has got 3 of the TMA 122 radars. It's a VA site, and there's a camera there for bus detection. And I've got 2 slides left, 1 slide left. Just one other product we have now is the Flex Vision. This is brand new to us. It's AI-based video detection. You can have 8 zones. You can have 4 outputs per zone. So you can say to the zone, it could be pedestrian bus, it can be pedestrian traffic, it can just be pedestrian on its own, and trucks. And that's brand new to us. We're working for Topaz approval for that, and we should have that sometime early next year. And that's it. I've just got red.
Thank you, Chris.
Sorry about the throat.
So, unfortunately, we haven't got time for any questions
Cheers.
at the moment.
See you later.
But much. Okay. Any questions?
Excuse me. Jesus.
Howard.
Hello.
If you
Howard.
just wait for them.
Howard.
Hi, Chris. Howard Saffer, Independent. How do you deal with vehicles being obscured behind other vehicles when you're looking for precise detection at a particular point?
You have to take a view on it, I suppose, on each junction in each situation. I mean, so it's kind of a case of placing the radar in the right place. I suppose if you had 2 lanes, for instance, and the first lane was heavily loaded with HGVs, you'd put it on the other side of the carriageway. And you might have to look at whether you might need to use 2 radars. The radars themselves they're looking for headlights. That's where these ones are. I'm not sure about the competition, but we're looking for a reflection from the headlights. So if you're looking down the side of the queue, that's where you're going to get your best reflections. Does that answer that in a way? You have to take a view. You can't. I don't think you could just put one up and it's when you're from a design point of view. You need to look at what the site's actually, how it's, what's running through it, and your best, where's the best place to position the radar.
I think that really feeds into the pragmatism we have to have in traffic engineering, the reality of it. Actually, there's the science, there's the engineering, and then there's the bit of magic as well. So maybe that's part of it.
Yeah.
Anyway, Chris, thank you very much. If you've got any other questions for him, he's got his stand outside.